Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So I'm Tim Laverty. I'm a program manager on the Windows Phone developer platform team. And a couple of my teammates are out in the audience, so some of which I'm going to show their code today. So, but feel free to ask questions as we go. We're a relatively small group, so just raise your hand and interrupt and let me know. So I have probably, I don't know, half slides, half demo, Visual Studio and demo both. So we'll pop back and forth. So again, this is about one of the larger pieces that we've added to the developer platform in Windows Phone 8 is native code, so getting C++ access. And I'll focus on where you can write it, what limitations there are, and recommendations as well. My email address is here and Twitter account is here, so if you have follow-up questions, just hit me up over mail or over Twitter as well. Okay. So C++, this is the C++ you know and love. This picture is my book from, I think, 1990 or so. And this is my 6th edition from this year, both from Stephen Prada. This is a great book. I would recommend it. And the reason I put this in here, it's kind of funny to think about. It's been a long time. But what we built or what we've added to the developer platform in Windows Phone 8 for you is C++ as you know and love it. There's nothing really special or super new here from a C++ perspective. You're just getting access to or we just added access to it from the platform. Okay, so you need VS 2012 to build apps for Windows Phone 8. This is the same as you need for Windows 8. There are a number of things that if you're not up and running on it already, you need a SLAT-enabled machine and so on. And I'll talk a little bit about some of the new C++ features, or C++ 11 standard features. Wow. OK. Sorry, that's hard. Can you guys see it in back? Jeff, can you see it? All right. So the C++ standard we support in Windows Phone 8 is a subset of C++ 11 features. There's a great blog post here from the developer or dev C++ team that I would recommend looking at. But it largely gives you pretty decent access to C++ 11 features. You have lambdas, you have the auto keyword for typing, you have null pointer constant, etc.
Was that the same as just what Visual C++ supports?
That's right.
Or was it smaller than that?
No, it's the same. What you see in Windows 8 in terms of C++ 11 standard support is exactly what you see in Windows Phone 8. It's the same compiler. Okay.
Is it managed C++? Or?
So we do not support managed C++, no. Same story as Windows 8. Yeah. Do you guys want me to repeat the questions as I go?
Yes.
OK. All right. I'll start doing it from here on out. OK. I wanted to hop into code pretty quick to just show a couple demos of how you can get at C++ in Windows Phone. And so I'll show a couple. So probably the easiest way to show how C++ can be used in Windows Phone is we have a set of project templates that are in the box. You have a pure native D3D app. You have a D3D with XAML app. And then if you go into the C# node, you'll also see a XAML and D3D app. Those latter two are just very slightly different, and I'll dig into detail a little bit with them later. They use a different control to render D3D2. But the first thing that I'll show is the pure native app. And if you click through this, or this is, I think of this template as it's a good way to bootstrap yourself with, if you want to write a Windows Phone app that is pure native, you don't want to have any XAML in your app whatsoever, this template gives you a really nice safe harbor for actually doing it. So if you take a look at, say, this is, so my Phone Direct 3D app 59 CPP, you'll see a number of, mostly what you'll see in this file that VS auto generates for you out of the template are the OS handler hooks. So you're seeing the system's initialize set window. If you come down here, you basically see your render loop, or your, well, not just your render loop, I guess, it's your simulation and render loop wrapped in one. So what's happening here is when your app starts up, the Windows Phone OS will initialize you, create your window, and then it will call run on this, and this is really where your code will be. So you have a timer, you have this dispatcher process events is basically handling input for you, or giving you a hook to trigger input. You have updates, so any of your simulation that would be added would happen either inside of this render update method, or you'd add it previous to it here. And then you have render and present, so actually drawing your pixels to screen. A little bit down below are your hooks for input. You get an input off of this args pointer, or sorry, off of this args argument. And here you have current pointer, and you can grab the position or the point off of this. So in terms of getting your feet wet, or having just something that shows you, well, how do I write my first C++ app? The template is a great starting point. You can walk in, it shows you how it hooks into the OS, and all it's doing is just drawing a triangle on screen. And let me go ahead and run it. That would have been much more smooth if I'd had the emulator booted up before. So all we're doing here is we have our square rotating on screen. If you want to look at how or cubes, I should say. So if you want to look at how the cube is rendered, you can walk underneath the cube render CPP file. And then if you want to look at how DirectX is initialized and bootstrapped so that that cube can render, you can look under Direct3D Base. This DirectX helper, I always think of this as a little misnamed. I guess we probably should have changed it. Is that, it's basically your I/O for reading your shader, or reading your shaders from disk, is all this is really doing for you. So I wanted to show that, and then the other thing that I wanted to show is this. It's a super simple demo of just getting up and running, but I did want to show and talk about some of why we actually. So why bother adding C++ support to Windows Phone? And some of the reasons are like this. So what it allows you to do is write systems with, actually.
Can we dim the overhead?
Is there a way to dim the overhead? Oh, is it here? Okay. So what it lets you do is you have access to pretty much about 95% of the platform as a whole. And I'll talk about the small missing pieces that you can't get to from native code. You also have access to Direct3D and programmable shaders. So this was actually built by our graphics team. And it's really more of a tech demo, and the idea is basically to show the extent that you can, leverage custom shaders and Direct3D on the phone. So this is writing apps that would showcase this kind of graphic fidelity was possible in some cases, but very, very challenging with with our managed platform. So what we've tried to do and opened up is letting you write apps that have much more graphics fidelity.
hard was it to develop that app?
So the question was, how hard was it to develop the app? It came from our graphics team, so it came from someone really, really familiar with the app. We plan on posting the source for you to take a look at it. I think it took him, I think it was like a 2 or 3 day effort. It was kind of one of our, kind of in one of the, okay, we finished our milestone, let's go write a whole bunch of code and go write a whole bunch of samples and demos to prove what we're doing. And it was during one of those times.
Okay.
Yeah. So significant, but not outrageous. I mean, you're talking about writing some fairly complex shaders and D3D code.
So the core question would, could you do that in the C#? I noticed that you had a project in C#. Could you get that level of fidelity?
Yeah, so the question is can I get that level of fidelity with just C#? So what I would say is probably not. That particular app uses a significant number of custom shaders, programmable shaders written in HLSL, so code executing on the GPU. However, and I'll talk about this in a little bit, is you can exercise or leverage D3D inside of your managed apps or inside of your XAML apps using our D3D controls. And I'll talk a little bit about the 2 controls that we've added that allow you to get at that in just a couple minutes. Okay. So that was my the basics of C++, getting your first C++ app up and running, and then my fancy shader demo. Okay, so I'll talk a little about your question right now, which is what are our application models? So are you limited in if you create an app, are you limited in using C++ in that app, depending on what model you chose? So if I built a Silverlight app, or if I built a XAML app, can I leverage C++ code from it? I showed graphics just now, and I kind of focused on graphics. There are a number of scenarios that aren't graphics related. So say I have an existing C++ library that I'm using for financials, or financial calculations, or just legacy C++ libraries that I'd like to use in my phone app. I'll talk a little about how you could leverage those, or if you can. And then, like I said, I think that some people get really excited about writing C++ or writing native code, and I'll talk a little about when and why we would recommend that you use it. Okay, so a little bit of a busy slide, so I'll talk through it. There are really 2 app models in Windows Phone 8 now. You have a direct 3D app, a C++ app, which I just showed, so based off of that template. It's pure native. There's absolutely no managed code running in it. The CLR is not loaded into the process. It is a to-the-metal app model.
So
yes, sir.
Data, you're talking directly writing right to the GPU.
Sorry, I didn't hear your question.
So when you say native, I just want to make sure I understand. If you're talking when I compile it, I go right to the GPU assembler language, or I get an intermediate language? So
the question is when I say native, do I mean am I writing real C++ real C++ code that compiles down to IL or to the metal? It's to the metal is the answer. Yeah. So there is no IL here. This is not managed code. You don't have a CLR running in process. This is actually native code. And I'll talk a little bit about how you mix the 2 over here. So you have the same XAML application model that you had before. So previously, or I should say very, very similar. You were writing Silverlight apps before. That same code, all of those skills you have around building XAML apps, laying out XAML forms are still 100% supported on the phone. We largely have 100% app compat for apps coming from Windows Phone 7.1 on Windows Phone 8. What we've added is the capability to, 1, interop with native code. The way that you call native code from a managed app is using the Windows runtime, or WinRT. And I'll demo in just a couple minutes of actually doing that, of creating a XAML app, and how do you call something that is native. Okay? You also have 2 additional controls that you can use in a XAML app. So controls just like your button or list box, etc. These are controls that you can place on a XAML app, and they are a D3D surface that you can render D3D into. Okay? Underneath both of these application models is a common API surface that is based off of, in large part, WinRT, but is accessible from both managed and from native code. Okay, so if I want to get it the file system, or I want to get it audio or video, etc., I can get it each of those through this common API surface. Okay.
So does it have different names, or is it same naming, or?
Sorry, can I hear that? You said
Does
again.
it have different naming, or is it the same name?
So the question is the API surface different names or the same name? Largely the same. There is some API surface that is, you'll actually see, let me think of an example. Say like for HTTP, there's a difference here in that you're using web client if you're writing managed code, but if you're writing native code, you need to go through IXML HTTP web request too. So a little bit different. But I mean, the core of your question, I think, is hey, if I'm writing managed code and I flip over to C++, can I write code that accesses the file system, or say networking, say Bluetooth, or say NFC, and are the APIs named the same? And the answer is yes. They're based off of WinRT, and I'll talk a little bit about how WinRT works. Essentially what you're doing is you are defining an ABI, so an application binary interface, and then that gets projected into C++ or C# or VB. So same exact API names and functionality here, just projected into the languages the language you want to write in.
So when I talk from Windows 27's perspective, suppose I want to use some sensor things. So I need to include some reference .microsoft something sensor, something like that. See, if I'm going to write some app on C# or C++, so do I need to make the same kind of reference, or is it going to be different?
It's the same.
Same thing.
So the question is if I want to get access to WinRT API, I want to get access to sensors, or I want to get access to Bluetooth, are the mechanics, like how I add a reference to it or place the namespace in my code, the same as they were in manage? And the answer is yes. It's actually even slightly easier. For WinRT APIs, the reference is there by default. So you'll just actually add the using to get at sensors. I'll show you in a couple minutes. I don't have it in my demo sequence, but I'll add it, and I'll show you. I'll show you what it's like to get it. So what I'll show is we'll build a WinRT component, and then I'll show how you get access to those that are built in as well, both of them.
Interoperability and all those things, right?
So let's wait on interoperability. The question was about interoperability. Let me keep going, because we'll hit this in the demo, and I'll talk about interop once we get there. Is that okay? Okay.
Another question.
Yeah, go ahead.
If you look at the SDK reference, it lists .NET APIs, WinRT APIs, and native.
Mm-hmm.
So are .NET APIs accessible from your native C++ app?
So the question was, are .NET APIs accessible from Windows C++ apps? And the answer is no. If I'm in a pure native app, then I do not even have the CLR loaded. So I can't get at those managed APIs. Now, if I wanted access to them, I could build a XAML app, use WinRT for my own custom native code or to wrap my own custom native libraries for where I wanted, and then use those managed APIs from my XAML code or my managed code.
I have some legacy code that reads some streams, binary streams, and one of them contains XML.
Mm-hmm.
And XML parser is in .NET API, not in managed. So it means I cannot access XML parser from C++ app.
That's correct. Yeah. Okay. Okay, so I think that the message for this slide, what it really says is if you want to use C++, it doesn't matter which app model you choose, you can. So you have access to it. Usually we recommend that if you're building your AAA games title, you're probably going to stick with either a pure native application model or potentially a XAML application model with probably the drawing surface background grid control. And I'll talk a little bit about why in a few minutes. And there are some small differences between the two D3D controls that you should be aware of. And then one thing that, like I said, sometimes we we say, hey, we've added native to the platform, and people get really, really excited. Not every app needs it. If you're very comfortable writing your managed app or writing your XAML app, you don't see a perf need or a portability need to write in a C++ code, then don't. I mean, there's a fair bit of complexity, and we'll talk about interop costs in just a few minutes that it's probably makes sense to stay away from. Okay, so the top 3 reasons that we added C++ to the platform this round were portability, reusability, and perf. Notice perf is 3rd. Obviously important, and there are some scenarios that you just can't accomplish using managed code. But our primary objective here was being able to write code and share it across our platforms and competitor platforms both. Okay. Let me talk about WinRT just a little bit. Okay, there's something. There's something a little bit off with the slide, so I'm going to flip back over to my PC. Oh, there it goes. Okay, so when somebody says WinRT to you, they're really talking about 2 things. They're talking about a runtime or infrastructure, and then the APIs that are built on top of that infrastructure. So on the left-hand side, you see here, you're talking about plumbing, a type system, this common programming model. On the right-hand side, you're talking about features that we pulled in from Windows 8, things like sensors, things like Bluetooth, and you're talking about our specific WinRT functionality. So platform features like, say, speech is probably a good example. Also on the right-hand side, if you're writing your own native library that's used in a Windows Phone app, you're very, very likely at least shimming it with WinRT. And I'll show in just a second how that's done. So it's runtime or infrastructure, and then separate from that, APIs. So actually features that you're leveraging. And as I said earlier, it's important to know that when you write your WinRT API, so you define that interface, part of the the thing that's one of the really cool things about WinRT is it's projecting into C++, into C#, and into VB. So when you write these WinRT components, you use them from any language is the idea. Okay, I think I hit most of this already. Okay, let's go over to code a little bit. So all right, so what I'm going to do is I'm going to take a simple XAML app and show you how you call native code from it. And then what I'm going to show is something a heck of a lot more complex than that actually Jeff McGlynn in the back wrote, that controls the Sphero. So it makes the Sphero roll around, okay, over using, it talks to it over Bluetooth. So there's, when I show it, well, I'll talk through it once I show it. So first, simple managed app calling C++ code. So in this case, I'll spin up a new C# app. And all I want to do is, when I click this button, I'm going to want to call some kind of something in native. So the way that you do this is you have a XAML app. The only way to call into native code from a XAML app that we support is by using WinRT. So it is your interop mechanism. Now, once you're inside of a WinRT component, if you wanted to link in libs or dynamically load libraries, you absolutely could. So it's not a question of, hey, I have these legacy existing DLLs or libs that I'd like to leverage. You absolutely could, but to get access to them from a managed application, you would need to wrap them or shim them using WinRT. So in this case, I'm going to add a new project.
Sorry, just to clarify, there's no more p invoke for
flat APIs and DLLs?
That's correct. We do not support pinvoke for Win32 APIs or DLL calls. The only interop mechanism that we support from XAML apps is WinRT.
I noticed there were a lot of flat APIs on the poster. For instance, activate, audio claim stuff. And that means I will be forced to use C++ if I want to interop with them from C#, I guess.
That's correct. If you want to interop with any Win32 APIs, D3D is mostly COM-based. We have a set of file I/O APIs that are Win32 based. Then you would need to wrap them inside of a WinRT component. And I'll show you right now how you can actually do that.
And it sounds like also COM interop won't work.
That's correct. Yeah. WinRT in large part is, I had a colleague say, well, WinRT is really COM with fancy metadata. So it is really COM under the covers, but if you're using legacy COM components, you can when you're inside of your WinRT component, but you cannot directly from your XAML app, from managed code. Okay, so I created my managed app, I put a form, or I have a form, I put a button on it. If I want to access native code from here, I can add a Windows Phone runtime component. Notice you have an empty DLL and static lib project type in here as well. To use those, you would need to go through this shim. So here I've added this Windows Phone or this WinRT component. And I'll write my extraordinarily complex calculation. Maybe. So all I've done is I added this Windows Phone runtime project. I took the header. I added our prototype for add something. It takes an A and a B. It returns whatever it adds. And then I've implemented it here. And I'm obviously not showing this to show the complexity of the code that you can write. What I want to show is the basics of how you actually do it. So far, I've got my managed app. I created my native app with my tiny add something method in it. Now I want to call it. So here I add a reference to it, not a service reference. And then so here I'll show you one of the things. So that's really it for how do you get at native code. So the absolute basics of, I write my managed app, I want to call something in native. What I just showed is really as much as it takes. Very simple. So I'll run it, and then I'll, I guess one thing to consider is one thing that we do not have, which we would love to have in Windows Phone 8, is mixed mode debugging. So I can't F11 or, sorry, I can't step into this. So if I hit step into, it just steps over it. If I want to actually step into my native code, then I need to come to the project settings, to the debugger, and just actually switch it to native. So this is something that can be somewhat painful as you're debugging is you're either debugging managed or you're either debugging native. So actually having to make that explicit switch. Once you're in, I mean, once you're actually debugging your native code, it's what you know and would expect out of your C++ debugger. So same locals, watch window, breakpoints, etc. So here it's breaking into native code as well. Okay. Questions before I keep going? Because that's the basics of how you interop or how you get to native code from managed. Yeah, hit it.
What about .NET file storage and native files streaming? Were they stored in the same place? How would you access the files that you save in both areas?
So the question is I'll make it concrete, is I write a file to ISO store using managed code. Can I read it from native? Or can I read it and rewrite it from native? Yes. There are some nice helpers for writing to ISO store if you're writing WinRT code, and I think that they work for managed code. I don't remember. Do you know? I don't know. There are some nice helpers for, like, you basically type like ISO store colon whack whack, and then it figures out what the ISO store path is and will help you write them. I know that they work for WinRT APIs mostly because that's what I use. I don't know about managed, but the answer to your question is there's no difference in terms of what your chamber has rights to write files to. You're writing to the ISO store location. And obviously you can read from your app install location for any art assets, models, meshes, etc. Make sense? Okay. Other questions? Yeah, go ahead.
I'm not sure if you're familiar with it, but today I stumbled upon, there's like, under WinRT, there's the graphics.interop and input.interop APIs.
Mm-hmm.
Not sure if you're familiar with those, but does that mean I have to use native code to use those?
So the question, under WinRT, can you get to graphics.interop and input.interop? I don't know. If you send me an email, I can go find out. Yeah. I got one more, and then I wanna keep driving through. Go ahead.
My question is just to make sure everything, native or managed, whatever you write to the files goes to ISO storage, right?
Yeah. So the question is similar to over here. Was if I use the file system APIs, so the IO APIs, do I get any additional access to where I can write to or where I can read from native or from managed, or is it the exact same? So if I write a file with managed IO APIs, is it the exact same as it is with native IO APIs? And the answer is yes. You write to ISO store, or you can read from your application install folder. That's it. So no difference between the two, and really no capability difference between the two either. If you're using the WinRT APIs, then you're executing the same code. You're just executing it, writing the C# projection or the C++ projection. It's no different. So same capability across the two. So someone asked earlier, how do you get at, well, actually, Jeff does this in his Sphero app. So I'll show the Sphero app real quick. So the Sphero app is super cool. It has a managed app that is a pretty simple GUI. This managed app handles I think that I've written a couple of these, but I think how we split it was the managed app actually does the Bluetooth communication with the Sphero device itself and opens a socket to that Sphero device itself. And then it hands that socket to a native app, which is this Sphero communicator. So it gives it a socket, a WinRT socket, and then the Sphero communicator basically handles all communication with the Sphero ball. So it tells it where to move and what color, and then actually hands back to the managed app any communication from Sphero that comes back. So mostly I think about color of the ball is what it does right now. And the way that the Sphero app moves is using sensors. So I'll talk a little bit about this in just a second. This is how you actually make the connection in Bluetooth. But all of this is managed code. Find. So I wanted to show where you get at sensors. So all you're doing, so this accelerometer is, I'll hover over it, it's a WinRT accelerometer object. All you're doing to get at it is when you declare it here, all you're doing is to say declaring accelerometer. Now, it's in the Windows devices sensors namespace, and there's a using statement at the top. There's no reference to any sensors binary that we've added. By default, you have access, or your app has access to all of the WinRT built-in runtime. So when you write this code, all you're doing is something along this line. You're saying, all you're doing is here, and then adding the using reference and immediately accessing it. So there's no, it's extraordinarily simple, and it's the exact same model that you're likely used to when you write managed code, when you actually access WinRT built-in functionality. So things like accelerometer, gyro, location, etc. Yes, sir?
So when you access these sensors and get all the data, is it the raw data that's from the sensor, you process it and then give the output?
So the question is when you access the sensor API, can you get raw data out of it, or what does it give you by default? It probably depends on what you mean by raw. Like, the sensor obviously there's a driver sitting above it that's passing you that data from the driver.
Operation on top of that, right?
Pardon?
There is no filtering or any of those stuff happening on top of the raw data.
I don't know the intimate details of how the communication works between the accelerometer gyro driver and the WinRT API, but the information that you get from it is basically raw. Yes. Yeah. So let me show the app. So this is a Sphero, and I don't have this phone set up for DUV out. I can use the Wolf Vision. It doesn't look as good though. Let me see if I have the Sphero app on here. No, I don't. Okay, I'll use the Wolf Vision. That's all right. Okay. So the one thing that you should recognize is that with Bluetooth devices, before you access a Bluetooth device from a Windows phone, it must be paired. So I've already paired this Bluetooth device, which is here, the Sphero BRR. So once you've paired it, it caches host information for actually talking to it. Can you guys see that okay? Okay. So, and then I'm going to pop over to Jeff's Sphero app. I added a fancy icon for it. And all we're doing here is, what it's doing when I hit Find Devices is it's using the Peer Finder API, which is the Bluetooth API, to go out, enumerate all Bluetooth devices paired with this phone. I've paired this next to, which is my robot. It's a Lego Mindstorm robot. I've also paired the Sphero right here. So I'm going to hit Sphero. I'm going to connect to it. And then you see, if you can see the Sphero. If you can't see it, feel free to stand up. But the Sphero's lighting up. And then after I hit calibrate, it's ready to go. So if I then move, then it basically has a stream socket that's running over RF comm open to the Sphero. And as I move my phone around, it's pushing the Sphero ball around, which is pretty cool. Yeah. I think one of the more yeah. I think some of the more satisfactory moments as a programmer you can get are when the first time that you get the ball to change color or helicopter rollerblades. It's not even flying it almost. It's just like the fact that, wow, I'm actually talking to this is super, super cool, I think. How this works with the device works with many devices or most devices that are Bluetooth enabled on the market. Most of them run over RF comm. We have a Sphero ball. Like I said, I have a robot, a Next car. I flew a helicopter at Build last week. I don't know if you saw that. That was actually running over sockets. But this, communication or the Bluetooth facility or capability is super cool here. Okay, so, and I should say that in good part, what makes that possible is adding C++ to the platform. Like my robot control application that I use with the phone, it's a purely managed application, and I can get at the Bluetooth APIs from that managed app. However, this Sphero has an SDK that is shipped that is already written in C++. So you could take that C++ SDK and you could port it to managed, or because you have access to C++ here, you could just plug it in. The same exact story for I demoed a quadcopter at Build last week, where the Parrot team who build the AR drone device that I was flying there, they ship a C++ SDK. You can use that C++ SDK on any platform. You write your C++ app, or you can use that engine to write your C++ app for Android, for iOS, and now for Windows Phone. So what we did with that quadcopter was we took Parrot's C++ SDK and we ported it, or we built it for the phone with some effort, but relatively minimal, especially if you compare to taking that existing C++ SDK and porting it to managed, so to C#. So this is when on a slide earlier where I had, near the top was a question of portability. These are some of the key reasons that we did it. There are so many C++ OSS libraries, you say like SQLite, or SDKs out there that are built for any platform that we would love to have access to. And previously, we were really pushing folks to port them to managed and port them to C#. And adding this to the platform makes it so we don't have to push like that. You just use it. Okay. How am I doing on time? I think I'm a little bit over. Yeah, okay. Okay. Okay, well, this wrap up anyway. So key takeaways. If you want to use C++, any application in Windows Phone can get at it. If you're managed, you are gated or forced to use WinRT as your interop layer. Once you get to C++ through WinRT, you do whatever you want. Link in libs, load your DLLs that you have from ages past, knock yourself out. Our primary reasons were around portability and code reuse. There are obviously some serious benefits around perf. And then last is I did focus a fair bit on the Windows runtime, both the runtime piece or the infrastructure piece and then the API piece. So I think that as you're building your C++ apps on the phone, you invariably will run into needing to have a pretty decent base of Windows runtime knowledge. So I would recommend spinning up on it pretty early. This is one thing I would suggest. I was going to add a resources slide here. So there are a number of things that I would suggest looking at. Herb Sutter's talk from a year ago build is actually very applicable to what you're talking about here, the C++ talk that he did. Peter Tor did a talk last week at Build that was specific to C++ for Windows Phone. It was kind of an expanded version of what I just did. I'd recommend taking a look at it. And I mean, otherwise, it's like you should start, there's pretty good docs for C++ for the phone, and you should start seeing more and more content and samples from the developer platform team. So that's what I had. Questions, yeah?
Why was PNVOC not included?
It was largely a question of cost and effort from our perspective to continue supporting it. And WinRT offers a great interoperability method and consistent story for marshalling and so on that we could, it basically was it could 100% replace or very nearly the pinvoke scenarios, and it drastically simplified things. That was why. Other questions? Mm-hmm.
While you've been speaking, I've been installing the SDK on my laptop.
Great.
Once it finished, it pegged one of my CPU's cores 100%, saying mobile device process. Do you know anything about this? I'm also struggling because it said hardware virtualization isn't supported.
So the question is about SDK install. I'll try it, just because this is one actually interesting thing that you should know about when you install the SDK. So you need a SLAT-enabled machine in order to run the emulator or to run the emulator on your box. I can show you how to actually detect that. You use a tool called CoreInfo. to find it. That's probably what the virtualization problem that you're seeing is. The other installation problem, I don't know. I'd have to look at it with you. I'm happy to look at it with you after. Yeah. Other questions? Okay. All right. Thanks a lot for your time.
Thanks.